Okay, cool. So, hey everyone, thank you so much for joining me today. This is the first episode in the OWASP Top 10 for API webinar episode. And today we are going to talk about the background for the project and the most critical vulnerability in APIs. So, in the next episode of the webinar, we're going to talk about the rest of the OWASP Top 10 for APIs. And would be dedicated to pen testers and explains how to break into APIs, more for like the pen tester perspective about API security. So today's agenda is first of all to understand why do we even need a new list for OWASP Top 10 for APIs. We all know the OWASP Top 10. The last list was published in 2017. And I'm going to try to explain why we need another list for APIs. And the second thing I want to talk about today is what is modern application security and what are the differences between modern application security and traditional application security. And then last but not least, to talk about the most critical API vulnerability, broken object level authorization, and to see how this critical vulnerability impacts many companies in the last few years. So before we even start talking about application security, let me just quickly introduce myself. My name is Inon Shkedy. I'm the head of security research at Traceable. I joined the company about 1 year ago, and we are solving API security problems and application security cloud native problems. I got 8 years of experience with application security, and this is just a formal experience. Before that, I used to be like more of a script kiddie, building phishing page and learning SQL injection exploits. And you might ask yourself, why should I listen to this guy about API security? So one of the reasons it's because I've grown up with APIs. So, and I've seen the few changes between traditional application security to API security. So what does it even mean? I started my career back in Israel. I used to be part of the red team of the Israeli army. I had fun time to break into government, military, and financial applications. As you can imagine, those applications are based on traditional technologies like Java, ASP.NET, SAP, and I got exposed to traditional concepts like multi-page applications, on-prem environments, waterfall, and API used to be just a niche component, mostly for B2B communication. So back in Israel, I used to be in this red team of the Israeli army. I used to find mostly the OWASP top 10, like things like cross-site scripting, SQL injection, CSRF, and so on. Then about 3 years ago, I decided to move to the Silicon Valley in California. And for the last 3 years, I've been working mostly with startups and tier 1 companies. And I got exposed to many interesting things in California. But if we talk about the tech field, I actually started seeing more and more applications that are written in Ruby on Rails, Node.js, Elixir, like very modern technologies. This is something that I didn't see before. And I got exposed to new concepts like single page applications, cloud environments, CI/CD, and the most important part, that all of these new things are driven by APIs. So the next thing that I found after I moved to the Silicon Valley is that I cannot really use my old ways to find vulnerabilities in APIs. Those modern applications are not really vulnerable to the traditional stuff that I used to find back in Israel. So I had to adapt my mindset and my methodologies in order to stay relevant in the field and to be able to find exploits, to find interesting stuff in APIs. So during the first part of the presentation, I want to talk a little bit what is the difference between modern application security and traditional application security, and why there is a need for a new list for APIs. So before we even talk about modern application security, I want to talk a little bit about modern application development and to explain what has changed in the last few years in the field of application development. So there are many exciting changes in the last 5 or 10 years in the field of application development, and you can ask every developer. But I'm gonna cover the more significant changes that also impact application security. So if you take a look here, you can see a traditional application, a traditional web application. This is the Yahoo web page from 2010. And this is a very traditional web application. Every click that you click, every link that you click, you get to a new HTML page. And on the other side of the scale, you can see a good example for a modern application, which is Google Drive. And this is a single page application. So you might still use your mouse and keyboard, but behind the scenes, everything looks completely different if we compare these two applications. So let's see some of the changes. First of all, if we take a look at the traffic patterns behind the scenes, things look very different. On the top of the screen, you can see what happens in traditional applications. The client would send a simple HTTP GET request to ask for a specific web page. In this case, is the home.jsp. Then the web server would process the request and fetch data from the database, which is usually SQL, in order to build this homepage, right? So it would fetch the notification, the news, the profile, and so on. The creation of the web page, which is the creation of the HTML page, would be done locally on the web server, and this visual page would be sent back to the client in the format of HTML, and then the browser of the client would present it to the user. And usually there is not a lot of JavaScript. It's usually HTML. The JavaScript is pretty simple. In modern applications, it looks very different. So first of all, clients know much better what they want. Clients don't ask for a complete rendered web applications. They ask for very specific pieces of information. For example, give me the last 20 notifications, or give me the last 10 messages from my inbox. So clients have much more context about what the user needs. And it's a very interesting change, because back in the day, if we think about the web servers knew exactly what is the state of the user. The web servers knew which clicks the user has clicked, and you had many features to support this type of thing, like view state in ASP and cookies. But today, the state of the user usually is maintained by the client itself, by a mobile application or web application. And then the API server, the web server in modern applications, is responsible to fetch data for this specific API calls from the client. So I like to think about that if you, in some way, APIs today are used more as a proxy between the client and the database. And they just fetch data from the database. And it's also important to notice that there are more types of databases. Instead of just SQL, you can find NoSQL, you can find Elastic. And another very interesting change, that instead of returning HTML pages, today web servers return raw data in the format of JSON. And if you think about it, the rendering component moved from the backend to the client. So today, all the rendering component, and rendering is the process of taking data and put it inside a visual page, is done by the client itself. A few other changes, if you take a look at the screen, you can see that you have more types of clients. On top of traditional browsers, you have mobile devices, you have IoT devices, and sometimes you even have other developers that use your APIs to build their own applications. And another very interesting change when it comes to APIs is that there are less abstraction layers. I had many people say, oh, but what does this mean, less abstraction layers? It has a few different aspects, but one of the more interesting aspects is today there is a shared language between the clients, the web servers, and databases. All of them speak in the same language of JSONs. I like to say that JSON is the new Esperanto. Many times, your object that is processed by your client is the same object that is also processed by the web server. In the case of NoSQL, it might be the same object stored by the database. So it's much easier for developers to pass data between the client and the APIs. A few other changes I want to talk about is, first of all, the rise of microservices. So back in the day, you could see many monolith applications, right? All of the components, the different components of the application would live in the same environment. The authentication mechanism, the payment mechanism, and the invoice mechanism would live on the same monolith app. And then in microservices, it looks very different. Instead of having one application, you have many different microservices. The business logic of the app is spread out across different components. And each one of these microservices might be written in a different language, in a different framework. And the second thing I want to talk about is the high phase of modern environments. So there are a few aspects of it. First of all is waterfall versus agile. Back in the day, you could see companies deploy new code to production every few months, even every several months. Today, code changes all the time, thanks to CI/CD and agile. On top of that, if you think about it, back in the day, if you wanted to spin up a new virtual machine, you should usually need to communicate with the IT team and to ask for a specific virtual machine, or maybe to ask to open a port on the firewall. So today it looks very different because of DevOps. Today, just a few clicks, and many times developers can just perform all these changes by themselves. They don't need the support from the IT team. It's more like something that the developers do themselves. A few other words about DevSecOps. So concepts like CI/CD, Kubernetes, Docker, and cloud environments brings good news and bad news. So on the bad side, so it's really hard to keep on track with the APIs because it's too easy to spin up a new API. As we said, it leads to a situation, it's also very hard to keep on track with them. It leads to a situation that many companies have shadow APIs. Those are API endpoints, or sometimes even API hosts that somebody created a while ago, and now there is no documentation, and nobody really knows what is the purpose of this specific API. And on the good news side, many of the classic issues like open ports, old versions barely exist in APIs. So let's talk about application security. If you take a look at the OWASP Top 10 2017, you can see that many of the issues become less and less relevant when we talk about APIs and modern applications. Let me give you a few examples. When we talk about SQL injections, many of them are solved by the use of ORM environments. These environments usually solve SQL injections by design. And by the way, do you know what is the reason the developers choose to use ORM? I'll give you a hint. It's not about security. It just makes their life easier to, and they don't need to write native SQL. If we talk about CSRF, because modern applications use authorization header instead of cookies in many cases, it solves CSRF by design. If your authentication mechanism is not based on cookies, there is no chance to exploit CSRF. Another good example is cross-site scripting. This vulnerability still exists in modern applications, but it's the responsibility of the client to protect against cross-site scripting. It's nothing about the backend, because if you think about it, APIs, like if we think about one single API endpoint, it might expose data that is consumed by many different types of clients, by mobile, by web, and by B2B clients. So it's the responsibility of the client to protect against XSS. And if we talk about path manipulations, vulnerabilities like directory traversal and the ability to write and read arbitrary files from the server, it's much harder to exploit it today, and it's less common to see them in the wild. Why? Because developers use cloud-based storage like S3. They still exist in those environments, but it's much harder to exploit them, and it's usually less severe and less common. And last but not least, if we talk about XXE, which is a great vulnerability that might allow, it's one of my favorites. It might allow me as an attacker to gain SSRF or even to close denial of service, but this is the vulnerability in the parsing process of XMLs. Because developers today don't really use XMLs, they use JSONs instead. we don't really see XXC in these cases. Let's move to the bad news. So one interesting thing about APIs, they become a very interesting and a very attractive target for attackers. And I think that the main reason is that APIs expose more attack surface. Let me explain this thing. So the first thing, there are more entry points. If we take a look at the dashboard component when it comes to traditional applications, you can see that the client would ask for one specific web page, which is dashboard.aspx. So it's only one entry point, right? But if we talk about the dashboard component when it comes to modern applications, you can see that there are at least 5 different endpoints to support the same exact component. For example, the APK version, which is the Android app, would consume 3 different endpoints, and then the APK version 4.2 might expose new endpoints, like the V2 of the API. So for the same exact component, in the case of traditional applications, you would need one endpoint, one entry point into your environment. In the case of modern application, it might be 5 or even more API endpoints or entry points. And the second point, more parameters are sent between the client and the servers. And as an attacker, why I'm talking about all this? Because as an attacker, every parameter, every entry point that you see, it's a potential area to exploit. So more entry points, more parameters, it's more interesting for attackers. The second thing is that APIs are oversharing. As we talked about, APIs expose less abstraction layers. And if you talk with the experienced pen testers that they have a lot of experience in pen testing, they would tell you that the best way to exploit applications is to understand what's going on the backend, what's going on the code side. So the thing is, many times when you perform a black box testing, it's really hard to understand what's going on the backend, especially with traditional applications. Fortunately, APIs expose many of the underlying implementation of the applications. And it allows it allows pen testers and security engineers to understand better what's going on the backend side, on the code, without even get access to the code. And the last point is that APIs are more predictable. Concepts like concepts like the REST standard and the GraphQL standard, they encourage developers to develop APIs in a very generic way. So it's very convenient from the developer perspective, from the client developer, like the front-end engineers, to use the APIs, but it also helps attackers to expand the attack surface much easy, in a very easy way. So for example, in APIs, I can just change from API/v1 to API/v2 and to find a different API. Or perhaps I can use API/admins instead of /API/users. I just change one word and I get exposed to an admin endpoint. It's very common. Yeah, so all of these changes led me to understand that there is a new attack surface. Attackers choose to exploit different vulnerabilities when it comes to APIs. And this understanding led me to join Erez Ilon from Checkmarks and lead the OWASP Top 10 for API project. So it's part of a bigger project of the OWASP API security. And the first thing that we try to do is to define the top 10 threats for APIs. And quickly we learned so it was a very interesting process to build this top 10 list that I'm going to talk about in this webinar and in the next webinars. So what we did is, first of all, we just collected data from bug bounty reports like HackerOne, BugCrowd, and many others to understand what are the vulnerabilities that are exploited today in the wild. The second thing that we did is to talk with many security engineers and pen testers that have experience with APIs and to understand what is the attack surface. And then we released the release candidate. I think it was about 6 or 7 months ago, and we got a lot of feedback from the OWASP community. So it's very important for me to emphasize that this top 10 list is something from the community to the community. It was a very interesting process to build it, and we got a bunch of feedback from very talented people. So this is the OWASP top 10 for APIs list. Today we're going to talk about just the first one, about broken object level authorization, which is number 1. And before we do it, I want to talk about the biggest challenge in APIs, the authorization. So if you take a look at the list, if we go back to the previous slide, you can see that we have 2 issues that are related to authorization: broken object level authorization and broken function level authorization. So authorization plays a very important role in those 2 issues. But on top of that, you can kind of smell a sense of authorization in almost each one of the items in the list. Authorization today is definitely the biggest challenge when it comes to API. And it took me some time to understand why, After some research, I believe there are 2 main reasons. The first one, authorization is not just one component. Like if you think about authentication, it might be something that you implement in one component in your code, maybe in a few components. But when it comes to authorization, it's very spread out. If we talk about object level authorization, it's something that you need to implement in every controller that receives input from the user, that receives ID from the user, which is almost every controller in your app. So it can be easily thousands of lines of code. If we talk about the function level authorization, this is something that can be implemented in the code level, in the configuration level, and sometimes even in the API gateway level. The second thing about authorization is that today in modern applications, you have very complex users and roles and hierarchies between them. So if we take, for example, some ride-sharing app, you can see that you have a user that has 2 sub-users, or another user like Jack that belongs to drivers and admins, 2 different groups. So it's much harder to define good policies to support this authorization mechanism. Let's jump into the most interesting API vulnerability, the most critical one, broken object level authorization. This is a pretty simple vulnerability to exploit from the attacker perspective, and it's also very severe. So let's try to understand what happens behind the scenes when you exploit BOLA. So as an example, I always like to give an example of ride-sharing apps because they're a good example for modern applications. So you took a ride on some ride-sharing app, and after you took the ride, you want to rate your trip, your ride, as 5 stars. So you click on the 5 stars button on the app, and then behind the scenes, your client would send an API call to post/API/trips/rate trip. But the problem is that you have taken many rides. So your client has to mention what is the ID of the ride that you want to rate 5 stars. And this is why your client would send this ID, 718492, to the API. And the problem begins in the API. The developers of the backend of the API don't validate that this ride ID actually belongs to your user. And because it's very common to do it, many times it's very challenging to check for this correlation. And then they just take the ID and update the record on the database. So if you're a malicious attacker, you could easily write a script to send a bunch of API calls and to rate all the trips or rides on Uber as 5 stars or 0 stars. And it can impact the business, right? If you rate all the drivers as 0 stars, it might have very significant impact on the business. There are many things you can do with BOLA. Sometimes it leads to leak details about other users. Sometimes it leads to full account takeover, and it's a very critical vulnerability, and it's definitely very common. I can tell you personally, in every API that I've tested in the last 5 years, probably in 95% of the cases, I found broken object level authorization. So every company basically is exposed to this vulnerability in some way. There are main 2 types of BOLA. One of them is based on the user ID. It's usually easy to protect against this type of vulnerability. The developers just need to compare the user ID from the param with the user ID from the current user object, which is provided by the framework. And then you have based on object ID. It's more challenging to protect against this type of BOLA, and we're going to see why right now. So in order to implement a good authorization mechanism that can protect you against BOLA, there are two components for this thing. The first one is the decision engine. This is some component that the company already has, and usually this component is developed by the more experienced engineers in the company. It might be a microservice, it might be a library, it might be just a function. Every company decides to implement it in a different way. And this component needs to be able to answer all the authorization questions about your application. And then the second component of the authorization is in the controller themselves. Every controller that receives ID from the client has to check with the decision engine if the user has access to the object that is represented by the ID sent by the client. Because if you're a developer, nothing can really prevent you from accessing directly the database. So this is the responsibility of the developers who write the logic of the controller to check with the decision engine. So let's see a few examples. So you have user number 585 who is trying to update profile number 616. This is a simple API call post/update profile. So what do you think? It's a legit behavior or not? So the answer, I don't know. It depends on the business logic of the application. Maybe some applications allow sub-users, and the user number 616 is a sub-user of 585. And it might be also like a malicious attacker who is trying to update the email of another user to reset the password. But all of these questions has to be answered by the decision engine, and the responsibility of the developers who wrote the profile controller to check with the decision engine what's going on. A different example, you have this user who is trying to access receipt number 777. So right here, before fetching the receipt object from the database, the developers has to check if this user has access to this object ID, to this specific receipt. So in the case of users, it's usually more simple because you have very clear hierarchies between, one user should have access only to his own account or maybe some sub accounts. But when it comes to other objects like receipts, it might be more complex. So in the case of Uber, I'm not sure if you know it, but you have an option to take a carpool ride. It means that you can share your ride with other riders. So in this case, you don't just have one-to-one correlation that one trip or one receipt belongs to one user. In this case, one receipt might belong to different users because different users has taken this ride together as part of the carpool feature of Uber. So all these questions has to be answered again by the decision engine. And the last example, if you have admin number 616, and this admin is trying to access the delete user functionality into delete user number 888. So what do you think? This admin should, because it seems that this, it's a legit flow, right? Because admins should be able to delete other users. It's part of the functionality of the app, but not necessarily, because in the case of Uber and many other big companies, you might have admins per region. So admin number 616 might be from San Francisco, but user 888 might be from New York. So this admin shouldn't have access to delete the user. Okay, so, because I've seen BOLA in so many places, I started asking myself why it's so common. I believe that the main reasons are, first of all, you have more IDs sent from the clients to the APIs. The REST standard encourages developers to send IDs in URLs. And many times, even if you build a good and decent decision engine, developers just don't use it. They don't check if they don't really check with the decision engine before fetching the object. And many of you might know BOLA in the older name of Insecure Direct Object Reference, which is IDOR. So I really like the name IDOR, it's cool, but it's not very accurate, because the problem when it comes to BOLA, it's not about the IDs, it's about the authorization mechanism behind the scenes that performs the validation that the user has access to the ID. I saw some talks and I saw some people talking about different solutions to solve BOLA or IDOR. Many of them don't really solve the problem. For example, if you replace your numeric IDs with GUIDs, it might provide you an extra layer of protection, and it might make the attacker life a bit harder, but it's definitely not a good protection against BOLA. It doesn't solve BOLA. If you rely on ID from the JOT tokens, and then you compare the ID from the JOT token with the ID in the request, it might protect you against some specific cases of BOLA, but it doesn't cover all the cases. And what solutions actually solve the problem? So first of all, you need to have a good decision engine, and then you need to make sure that developers actually use it in every controller. So I want to show you a few examples from the recent time for BOLA exploits. This one is very interesting. It was in Uber. It was found by the researcher Inon Shkedy from AppSecure. And as you can see on the screen, this is a simple post request to get constant screen details. This endpoint returns you details about the current user in order to populate this get constant screen details. So the details contains the first name, the last name out of PII. And what Anand found, that, I mean, if you're accessing your own user ID, it's not a big deal because you should have access to these details, right? But Anand found that if it changes the ID in the request to an ID of a different user, it might be either driver or rider, he can actually take all the details about this user, including the PII. And the most interesting part, this API endpoint also returned the authentication token. So you could just use it in order to log in on behalf of the different user, and it was basically full account takeover. A second interesting vulnerability, I think it was found a few weeks ago by Poya Darabi, and sorry if I'm not pronouncing the name right. This vulnerability in the Facebook business platform allows you to delete every photo of every user on Facebook. So apparently, Facebook exposes a special feature for business accounts that allow you to create, it's called series. So you can create a series of photos or a series of videos. It's more like different episodes. And during this creation process of the series, you can import different photos that you want to include. So you could change the ID of the photo that you want to include. You can see it here on the screen, to a photo of someone else. And then after you delete the series, you would also delete the photo of the different user. So it basically allows you to delete every photo on Facebook. Yeah, so this is the end of the presentation. I hope you enjoyed it and understood what are the differences between traditional application security and modern application security, and you got a better background about BOLA. In the next presentations, in the next episode of the webinar, we are going to talk about the rest of the vulnerabilities. And the last one is, as I said at the beginning of the presentation, part number 4 would be about how to exploit APIs. And I think we got some time for questions. And by the way, feel free to ping me on Twitter or LinkedIn, or you can also feel free to send me emails to my email account. Any question, guys?
There is a question coming in on the Q&A window, which is on the right side of Zoom.
Yeah, definitely. So we see that there's a question. You mentioned that multiple API endpoints increase the overall attack surface, which I completely agree. As an alternative, will using something like GraphQL decrease that attack surface since it's technically one endpoint in the traditional sense? It's a great question. GraphQL is kind of a new field of security. Many pen testers don't really know how to handle with it. But the reality is that in some way, GraphQL provides you more security because it's easier to follow which API endpoints you expose. But on the other hand, GraphQL exposes very interesting functionality. For example, one of the endpoints of GraphQL is to return all the functions that are exposed by the GraphQL. So I agree that there is some benefit of using GraphQL, but at the same time, there are many other security pitfalls that you might expose. Another question that I see from Ashley is that what's the best way to solve machine-to-machine API communications when there is no user context for the API client? How do you protect for BOLA in this case? It's a really, really good question. One of the things that we do at Traceable is to solve exactly this type of problems. But if we talk about more from the code perspective, one thing that I see that many companies start doing is to propagate the joke token. So let's say that you have your Edge APIs here and the user send a request. So in the internal API calls to the internal microservices, you want to pass on this joke token. So each microservice can validate the joke token and the credentials inside the joke tokens against the IDs that they're requesting. Yeah, about any good references to read more about the project. First of all, you are more than welcome to follow me on Twitter. I published some API security tips. A few months ago, I created the 31 days of API security. It's basically every day I posted a new tip about API security, and you can find the complete list on my Twitter account. Other references, I would encourage you to go to the page of the project of the OWASP Top 10 for API project. And also, if you go to YouTube and Google and look for OWASP API Top 10, you can find a bunch of good videos from me and other folks from the industry that talk about the project. Cool. I think these are all the questions. If you have any other questions, feel free to send me now. Cool. So that was the first webinar. It was really fun. I hope you enjoyed it. And please join me in 2 weeks for the next webinar. And we are going to talk about 4 security vulnerabilities in APIs, API 2 to API 5. It's going to be a lot of fun. We're going to see real examples from the recent times and to see how big companies got breached because of the vulnerabilities, including Facebook, Uber, and YouTube. Have a good day, guys, or good night. Bye-bye.